Okay, we continue today with problems on uniform circular motion. Okay, let's go to number 7. Over its last revolution before release, as a hammer carves a circle of radius 1.4 meters in 0.45 seconds. Assume that this last revolution is at constant speed. And then letter A, what is the speed of the hammer? So we are given the radius of the circle 1.4 meters and the time it takes to complete that rotation, that revolution is 0.45 seconds. We can compute for the V sub s, okay, using the equation V sub s is equal to 2 pi r all over t. Okay, so we have the radius and you are also given the time, it's 0.45 seconds. We substitute pi is 3.14. The radius is 1.4 meters, that's a given, and the time is 0.45 seconds. Okay, so let us compute 2 times 3.14 times 1.4. Okay, you will get 19.53. Okay, this is 19.53 meters per second. Okay, so we round this off to 2 SF. You will get an answer 20 meters per second. Okay, this is our answer for letter A. Letter B, what is the magnitude of the centripetal acceleration? So we are looking for A sub C. We know that the equation A sub C is V squared over R. Okay, so we have already computed for V. Okay, so 19.53 meters per second. Then we square this divided by the radius. The radius is 1.4 meters. Okay, so let us compute. Square the speed divided by 1.4. We get an answer 272.66 meters per second squared. So we round this off to 270 meters per second squared. Okay. Letter C, express this acceleration magnitude in G's. Okay, so in terms of G, this would be divide this by 9.8. Okay, so divide this by 9.8. In terms of G, okay, this would be 270 meters per second squared divided by 9.8. Okay, meters per second squared. That will give us 27.82 G. Okay, so round this off, you get 28 G. Okay, so ibig sabihin, 28 times 9.8, you will get 270. Okay, somewhere near that value. Let's go to the next problem. Okay, number 8, an electron moves in a circular path with a radius of 0.10 meters at a constant speed of 2 times 10 raised to the 6 meters per second. What is the period of its motion? Okay, so to get the period, we have the formula before. Okay, for the period, we have T is equal to 2 pi r over V sub s. Okay, so we have this from the second slide. Okay, so 2 times 3.14. The radius is 0.10 meters. And the V sub s is given 2.0 times 10 raised to the 6 meters per second. Okay, so let us compute. You will get 3.14 times 10 raised to negative 7 seconds. Okay, meters and meters will cancel out. Okay, so you will have this. Um, then we round this off to 3.1 only kasi 2SF to 2SF, 2SF. So 3.1 times 10 raised to negative 7 seconds. Okay. Now for letter B, what is the centripetal acceleration of the electron? Okay, so A sub C is equal to V squared over R. So we already have the V, it's given 2.0 times 10 raised to the 6 meters per second. Then we square this divided by the radius 0.10 meters. Okay, so upon computation, you will get 4 times 10 raised to the 13th. Okay, so we answer in 4SF, you get 4.0. Sorry, 2SF 4.0 times 10 raised to 13 meters per second squared. This is the acceleration, okay, of the electron. Okay, napakabilis ng kanyang acceleration. Okay, number 9. What centripetal force is needed to keep a 2 kilogram sack of flour moving at a constant speed of 4 meters per second in a circle having a radius of, okay, letter A, 4 meters muna, and then letter B, 8 meters. Okay, so ano ang difference din nila? Okay, so for number 9, our working equation would be F equals m v squared over r. Okay, the m is 2 kilograms given, and the speed is given 4 meters per second, square it, then divided by 4 meters. Okay, so we compute for this. You get 8 newtons. Puro 1 SF lang siya, yung letter A. For letter B, same formula. So m v squared over r. So the mass is still 2 kilograms. The speed still 4 meters per second. But then this time, the radius is 8 meters. Okay, so we expect it to be lower. So the answer is 4 newtons. Okay, so ito ang kanyang mga sagot for number 9. Alright, let's go to number 10. Number 10, Curious George is swirling a 2.0 kilogram bunch of bananas on a smooth floor in a circular path having a radius of 0.5 meters. What force must he apply to keep the motion constant so that the bananas complete only one revolution every 4.0 seconds? So we are given here uh, the omega. Okay, so oops, one revolution every 4 seconds. So that is omega. Omega is equal to 1 revolution over 4 seconds. Okay. Now we can convert this to radians per second. Okay, so 1 revolution is equal to 2 pi radian. So ang isang buong circle kasi 'di ba? Pi is 180. So 2 pi is 360 degrees. So in any computation here, we always convert revolutions per second to radians per second. Okay, so when you do that, you will get, so 2 times 3.14 divided by 4, you will get 1.57 rad per second. Okay, this is 1.57 radians per second. Now, there's a formula for the A sub C. The A sub C is equal to, this is another formula, it's equal to omega squared. We are going to derive this. Okay, next time when we go to rotational motion. But for now, this is a new formula for the centripetal acceleration. So please take note of this formula. I'll put this in a box. Okay, so for the first centripetal acceleration formula we have, it's v squared over r. Now, if you are given the angular speed, omega is the angular speed, then the equation, sorry, okay, this is angular speed. Okay, so the equation becomes this, okay, r omega squared. This is a Greek alphabet, okay, omega. Okay, so the capital letter is this. This is the small letter. It's a lot W with a tail. Yan. So the radius is given. The radius is zero point 0.5 meters. Okay, that's our R. And then the omega, we have converted it to radians per second. So radians per second, then square it. Okay, so our A sub C, we need that A sub C to solve for F. Okay, so 1.57 squared times zero point 0.5, you will get 1.23. Okay, so this is 1.23 meters per second squared. Okay, so you see there's when you multiply meters with radians, radians will disappear. Okay, so it becomes meters, and then this one is squared, so meters per second squared. Okay, the radian is it's a complement, it's a supplementary unit, so it appears and disappears without cancellation. Okay, but we are looking for the F here, so F is equal to m times the A sub c that we have computed, the centripetal acceleration. The mass of the bananas, 2.0 kilograms, multiplied by the A sub c that we have solved, meters per second squared. Okay, so what is 2 times, you will get 2.46 newtons. Then we follow the rules on significant digits. Everything is in 2SF here. So we make it 2.5 newtons. Okay, this is our answer for number 10. Okay, let's go to number 11. Number 11, Tommy, who has a mass of 30 kilograms, sits 4.0 meters from the center of a merry-go-round that is rotating with a period of 10 seconds. So that's the time that's given. What is the centripetal force acting on Tommy? Okay, so we use the formula again. F is equal to m v squared over r. Everything here is given. Okay, so the mass is 30 kilograms, the mass of Tommy. The v is, okay, the v in number 11 is not yet given, but we can compute for this. Okay, okay. So, ito pala yun. It's v squared. But it's not given directly na v squared. Sabi niya, it's a merry-go-round. So, a sub c, okay, compute muna natin. A sub c is equal to, remember this formula from the second slide? A sub c is equal to pi squared r over t squared. Okay, so 4 times 3.14 squared times the radius, which is 4.0 meters, divided by the time, 10 seconds. Okay, 10 squared. Okay, that would be our A sub c. So let us compute for A sub c. So 4 times 3.14 squared times 4 divided by 10 squared. You will get A sub c 1.577, 1.577 meters per second squared. Okay, so ito na yung substitute natin. V squared over R is this one. Okay? But it's not given as in terms of V. Binigay niya kasi yung period of 10 seconds. We can compute for the A sub C there. Okay, so 1.577 meters per second squared. So multiply by 30. you get 47.32 newtons. Okay, so everything, look at this is 1 SF, 1 SF, so our answer will be 50 newtons. Okay, let's go to number 12. Lulu wants to swing a 0.10 kilogram Twinkie. It's a parang ano to eh, parang cake, no? Yung rectangular in shape, tied to one end of a cord in a horizontal circle of radius 0.50 meters with a tangential speed of zero point 0.2 meters per second. Now, the word tangential speed is given. That is our V. Okay? So, yan yung V na sinusolve natin, ginagamit natin for solving all throughout. Ito yon. This is the V because it is tangent to the circular path in uniform circular motion. So when you solve for A sub C equals V squared over R, the V that you're getting is the tangential speed, tangent to the circle. Okay, by definition of a circle, when you draw a tangent line, it touches. Okay, it's perpendicular to the radius and it touches the line at only one point. So it's tangential. So itong velocity na to tangential and it's given 0.20 meters per second. Okay, what centripetal force must she exert on the mass? So F is equal to mv squared over r. Let's check if everything is given. The mass of the Twinkie is 0.10 kilograms. Okay, the tangential speed is given 0.20 meters per second, then square it, and the radius is given. The radius of the horizontal circle is zero point 0.5, okay, meters. We can readily compute for the force. Zero point 0.1 times zero point 0.2, you have to square this, divided by zero point 0.5. Okay, so maliit nun. The units are consistent. It's in MKS, so kilograms, meters per second, and meters. And the answer is very small, so 8 times 10 raised to negative 3 newtons. Okay, so this is our answer. Okay, let's go to the next problem, number 13. Brewster applies a force of 10 newtons to one end of a cord to keep a bag of rubber frogs tied to the other end, moving at a speed of 2.0 meters per second in a horizontal circle of radius 3.0 meters. What is the mass of the bag of frogs? Okay, so ang hinahanap dito ni yung mass, no? So yung F equals mv squared over r, we have to do a formula transformation for that. So mv squared over r. Ang hinahanap ito. So the mass is equal to F times r divided by v squared. Okay, so 10 newtons ang ginamit na force na inapply ni Brewster. The radius is 3.0 meters and the speed 2.0 meters per second. And then we square this. Okay, so what do we get? 10 times 3 is 30 divided by 4. So you get 7.5 and the unit in MKS would be in kilograms. So this is in kilograms. Okay. Okay. But according to the number of significant figures, it should be 1. So 8 lang. 8 kilograms. Kasi ito 1 SF yung 10. Okay. Let's go to number 14. Number 14, you are asked, Heather drives her Super Beetle around a turn on a banked circular track which has a radius of 200 meters. The Super Beetle has a mass of 1,500 kilograms and Heather maintains a speed of 20 meters per second around the turn. What centripetal force does the track exert on the beetle? Okay, so ano daw yung centripetal force? When you say banked circular, kasi usually dapat flat yung circle, no? But this is banked. So, yan. Now, no effect in the problem that we have. We are still going to use the formula F equals mv squared over r. Okay, so F is equal to mv squared over r. So the mass of the beetle is 1,500 kilograms. The velocity given is 20 meters per second. We have to square this. And then the radius is 200 meters. 200 meters. So 1,500 times 20, the speed, divided by 200. You get 3,000 newtons. Okay, so we get 3,000 newtons here. So the answer is in 1SF. Okay, this is 1SF. Okay, let's go to the last problem, number 15. A 76 kilogram pilot at an air show performs a loop-the-loop. Okay, so loop-the-loop is paikot. No? At the bottom of the 52-meter radius loop, the plane is moving at 48 meters per second. So vertical yung circle niya. So, umaakyat kasi, no? Pag ganito yung plane, no? So, you have this. When the airplane is here, the speed is said to be 48 meters per second. Okay, so nandito yung vertical. The radius of the loop, 52 meters. Determine the normal force. So pag normal force, it would be the force opposite the centrifugal force. Yun yung normal force. Okay, so yung upward acting on the pilot. Okay, so nandito kasi yung pilot, and then the plane will have to exert a normal force on the pilot. Okay, so when we do the sum of forces along the y, actually that is equal to 0. What are the forces along the y? You have the force, which is the weight of the person. Okay, it's negative. Okay, and then ano pa yung force acting on the person? It would be the negative um, F sub c, the centrifugal force, which is headed downward, plus the normal force. It's equal to 0. The normal force is the force acting. So let's magnify this, huh? So the person is on the plane. Because of the centripetal force, you have that F sub c here. Because of the weight, you have this Fw. And then the plane's floor or seats, no, will have to exert a force upward to keep the person in place. No, that is what we need to solve. So F sub n would be equal to Fw plus F sub c. But what is Fw? Fw is the weight, okay, of the person. So Fw is 76 times 9.8. We just convert it. You get 744 newtons. So 744 newtons. Now, how do we compute for F sub c? F sub c, we can compute using F sub c is equal to mv squared over r. Okay, so the mass of the person is 76. The v, the speed is 48 meters per second. Square it, divided by the radius of the loop. The radius of the loop is 52 meters. Okay, so 76 times 48, square this, then divide by 52. We get, okay, this is 3,367.384 newtons. Okay, so we substitute that here. Hindi muna tayo magra-round off. This is 0.384 newtons. Okay, we add this with 744. You get 4,111. So the F sub n is 4,111.38 newtons. Okay, So the F sub n, when we round off to 2SF, it becomes 4,100 newtons. Okay, this is our F sub n. Okay, thank you very much.